This is Bob Capetta from the College of the Florida Keys, and this lesson is on compound inequalities. Let's do a quick review of the standard approach that I use for inequalities. So if I'm looking at something like negative 4x is less than or equal to 12, you may be tempted to divide both sides by negative 4, but that's dangerous. If you do that, you have to switch the sign. My preferred strategy for dealing with inequalities is to solve it as an equation, make it equal, and then test points. So if I solve it as an equation, negative 4x equals 12, divide both sides by negative 4, we get x is 12 divided by negative 4 is negative 3. That's what I call a cut point. So I lay out my number line with negative 3 in the middle. That is a solid dot. I'm going to choose numbers on each side of that negative 3. To the right of negative 3 could be 0. I always like 0. That's the easiest thing to plug in. To the left of negative 3 might be negative 5. And we're going to check to see if the original equality is true or not. So I have negative 4x less equal 12, plugging in 0. Negative 4 times 0 less equal 12 is 0 less equal to 12. That's yes. So I'm going to shade that side. Next up, we have negative 5. So negative 5 is to the left of negative 3. So we're going to see if that's yes or if that's no. Negative 4x less equal 12. Plug in negative 5 for x. Negative 4 times negative 5 less equal 12. 20 less equal 12. And that, of course, is no. And usually one side will be shaded and the other will not. There's rare circumstances where it's not the case. And then we'll express our answer in interval notation. Because it's less than or equal to, this is a solid dot. Because it's a solid dot, it's a square bracket. Because it's going to the right, opening to the right. Negative 3, it goes all the way to plus infinity. We never actually get to plus infinity, so we put a round bracket around that one. Now, what we're going to do next is we're going to put a couple of these things together and see what our answer will be when that happens. So if I have something like x plus 3 is greater than negative 9 and 2x is less than 14. I want to find out which points are true for both. This is and. Remember, when you see and, you think intersection. And on a street, if there's an intersection on a street, the intersection here is really on both streets simultaneously. So intersection means I've got to find points that are true for both of these. So two cases. Case 1, x plus 3 greater than negative 9. Case 2, 2x less than 14. So I'm always going to first do an equal. So let me say x plus 3 equals negative 9. Let's add negative 3 to both sides, and I get x is negative 12. And then I want to shade where negative 12 is my cut point. So I'm going to draw my number line with negative 12 in the middle, and I'm going to test on either sides of negative 12. So negative 12 is here. That is open. Now, where is 0? Negative 12 is a negative number. 0 is to the right of negative numbers. 0 goes here. So I've got x plus 3 is greater than negative 9. Is that true or is that false? X plus 3 is greater than negative 9. 0 plus 3 is greater than negative 9. 3 is greater than negative 9. Having $3 is better than owing 9. That's yes. So we will shade towards the 0 here for this piece. Now, to the left of negative 12 might be, I don't know, negative 20. You can choose anything you want to choose. Then I have x plus 3 greater than negative 9. Negative 20 plus 3 greater than negative 9. Negative 20 plus 3, negative 17 greater than negative 9. Is owing $17 better than owing $9? That's no. So indeed, that is my shape for the first one. I'm not going to interval notation this until the very end, though, because I want to do both of these. And for me to work this problem, I need points that are true on this graph and the one we're going to get for this one. I have an inequality. I like to do it as an equal. So I'm going to say 2x equals 14. Divide by 2, divide by 2. X equals 7. We're going to lay out our number line. 7 is here, also an open circle. We're going to choose numbers on either side of 7. Something to the left of 7, less than 7 would be 0. Something to the right of 7 might be 10. 14, I'm plugging in 0. Is 2 times 0 less than 14? Is 0 less than 14? That's yes. So we're going to shade this way here. And on the right side, we're going to choose 10. Again, 2x less than 14, plug 10 in for x. 2 times 10 less than 14, 20 is less than 14. Is that true? That's a no. So now I have these two segments. I have those two segments, and I need to link them with an and. So where are they true? What parts are true? So let's draw another line segment with both -12 and 7 on it, and we need to see where those are. Just for fun, 0 is in the middle. -12 is somewhere to the left. 7 is somewhere to the right, certainly not drawn to scale. So I need places where both of them are true. Places where both of them are true. So if I'm starting at -12, I am shading to the right. If I'm starting at -7, I am shading to the left. Which points are both of them true? Which points are both of them true? All of the stuff in the middle. And means intersection, and means it's on both streets at the same time. If I do this in interval notation, what am I going to get? Round bracket, -12, comma, 7, round bracket. Notice I did not get to those points. I did not get to the endpoints. That's as far as I'm going to get. So I'm not actually getting there, so I've got to go with round brackets. That's an and situation. Let's take a look at another and situation written in a slightly different fashion. This time I'm going to say -6 less equal 2x plus 4 less equal 20. So this is actually an and statement. This is actually a compound inequality. So I like to break it up into its two pieces. -6 less equal 2x plus 4 and 2x plus 4 less equal 20. So these are the two things I have to solve, and I've got to find the points that are common to both. Find the points that are common to both. So I'm going to do this as an equal first. -6 equals 2x plus 4. Subtract 4, subtract 4. -10 equals 2x. Divide by 2, divide by 2. -5 equals x. So for my first situation, -5 is my cut point. And you'll notice it's less than or equal. If that's the case, make it a solid dot. We want to try something on both sides. To the right of a negative number is a positive number. My favorite non-negative number is 0. To the left of -5, I don't know, maybe -7. I always like to test 0 first. So let's test 0. And all up here to the blue, -6 less equal 2x plus 4. Plugging in 0, I get -6 less equal 2 times 0 plus 4. -6 less equal 4. That's yes. So I shade this way on this graph to the right. The other version, we have again -6 less equal 2x plus 4. Plug -7 in for x. -6 less equal 2 times -7 plus 4. -6 less equal -14 plus 4. -6 less equal -10. Is owing 6 worse than owing 10? That's no. So sure enough, that's the piece I have. I have shaded in that direction. Coming over here, what do we have? I have 2x plus 4 less equal 20. So I have 2x plus 4. I'll do it in orange to be consistent. 2x plus 4 equals 20. Subtract 4, subtract 4. So we get 2x is 16. Divide by 2, divide by 2. X is 8. So then what we're going to do is we are going to lay out our number line and test. 8 to the left of 8 is 0. To the right of 8 is 10. So 2x plus 4 less equal 20. I always like to test out 0 first. 2x plus 4 less equal 20. Plug in 0. 2 times 0 plus 4 less equal 20. 0 plus 4, 4 less equal 20. That's a yes. So we'll shade to the left. Over here, plugging in 10, 2x plus 4 less equal 20. Plugging in 10, 2 times 10 plus 4 less equal 20. 24 less equal 20. That's no. Now, the key word for us to work with here is and. I need this line, or this ray and this ray. What points are in common to both? So this is what I like to do, and we're going to lay these out. Where's your number line? Where are these? 0 is here. -5 is to the left of 0. 8 is to the right of 0. They're both solid dots. And which way are we going? From the -5, we're going to the right. From 8, we're going to the left. What's common to both? And where are they both true? They're both true in there, so that's what it would be shaded. In interval notation, what are we going to get? Square bracket, -5 to 8, square bracket. Now, there is a much shorter way to do it. I'm not thrilled with that strategy because I think it loses meaning, but I do feel that I should show you that. So what I will show you next is the way that this is taught traditionally. -6 less equal 2x plus 4 less equal 20. Is done sort of like an equation. Subtract 4, subtract 4, subtract 4. Then I get -10 less equal 2x less equal 16. Then we divide by 2, divide by 2, divide by 2. And you get your answer in no time at all. X is more than -5, less than 8. So that still gives us the same picture. And on occasion, I could understand you doing it this way, but this does cause problems. This can cause difficulty if you have negative numbers, a negative coefficient on the x. You can have problems there. You can have problems and you're not going to see situations where there's no solution. So there's several circumstances where this method is not going to work, but in this case it certainly does. So it would be fair to use. Now, those were all and cases. Let's take a look at an or case and how do we express that in interval notation. So if I have something as simple as x is less than or equal to 2 or x is greater than 6. Or is a union, you throw all the points in that show up anywhere. X is less than or equal to 2. Here's 2, here's your cut point. To the left of 2 is 0. Is 0 less than 2? It is. We shade this way. X is greater than 6. Open circle 6. 7 is greater than 6. 8 is greater than 6. Shade this way. Or means anything that is anything that shows up is used. So here's 2. Here's 6. Here's our first thing. Here's our second thing. If it were and, there is nothing that is common to both. But with or, anything that shows up, what points show up either in the first one or the second one or both? It would be this way, together with this way. Now, how do we express that in interval notation? What do we say? We say negative infinity, comma 2, square bracket, union, round bracket, 6 to positive infinity. So we express it that way for an or situation. So let's do one more of those just to get a feel for how the or questions work. So we will say 2x plus 5 is less than negative 9, or 3x minus 6 is greater than 1. So we'll do it as an equal. 2x plus 5 equals negative 9. Subtract 5, subtract 5. 2x is negative 14. Divide 2, divide 2. X is negative 7. So negative 7 is our cut point. We'll put negative 7 in the middle of this. Open circle. 0 is on this side. 2x plus 5 less than negative 9, plug in 0. 2 times 0 plus 5 less than negative 9. 5 less than negative 9, no. Plug in negative 8 on this side. So we'll say 2x plus 5 less negative 9. Plug in negative 8. 2 times negative 8 plus 5 less negative 9. Negative 16 plus 5 less negative 9. So that's negative 11 is less than negative 9. Owing $11 is worse than owing 9. That's yes. So we're going to shade towards the yes on this one. We'll do the same thing on the right side. We have 3x minus 6 greater than 1. I will do it first as an equal. 3x minus 6 equals 1. Add 6 to both sides. 3x equals 7. Divide by 3, divide by 3. X is 7/3, which is a little bit more than 2. So we'll lay out our number line with 7/3 in the middle. Lay out our number line. 7/3 is in the middle, and it's an open dot again. 7/3 is a little bit more than 2. To the left is 0. A little bit more than 2, I don't know, 5 would be a good one to choose. So 3 times x minus 6, is that greater than 1? Plug in 0. 3 times 0 minus 6, is that greater than 1? Is 0 minus 6 greater than 1? Is On the right, 3x minus 6 greater than 1, plug in 5. 3 times 5 minus 6 greater than 1 is 15, minus 6 greater than 1 is 9 greater than 1. That's a yes. So we're going to shade this way. And now our key word here, our operative word here is or. Whatever points are in one set or the other or both get used. So how do I make sense of that? Well, I have these two number lines. When I lay it out, I have -7 here. I have 7/3 here. I have 0 in the middle, just so I keep track of where 0 is. I am shading to the left of -7. I am shading to the right of 7/3. And if it were and, there is nothing in common for both. If the question asked for and, it would be no solution, but it asks for or instead. It asks for or instead, so I wind up shading any point I see that's in one set or the other or both. And that's what that looks like. In interval notation, we will say -infinity to -7 union 7/3 to +infinity. And that will conclude this lesson.